All right, so the next thing we're moving to is graphs of simple rational functions. Now, when you're sketching graphs of simple rational functions, um, more than likely your graph, your final graph is going to be a transformation of the graph of y is equal to, the graph of y is equal to 1 over x, which looks like this, or the graph of y is equal to 1 over x squared, which looks like this. All right, so this is y, y-axis, x-axis, x-axis, y is equal to 1 over x, and this is y is equal to 1 over x squared. For both graphs, the x-axis and the y-axis are horizontal asymptotes and vertical asymptotes, respectively. So example 48 is asking us to sketch the graph of f of x is equal to 2x plus 3 over x minus 1. Now, the first thing is this: 2x plus 3 over x minus 1 is an improper rational function. Now, what makes it improper? A rational function is an improper fraction, or is an improper fraction if the highest power of x in the numerator and the denominator is the same, and if the highest power of x in the numerator is greater than the highest power of x in the denominator. I'll say that again. 2x plus 3 over x minus 1 is an improper fraction. What makes it an improper fraction? It's an improper fraction because the highest power of x in the numerator and in the denominator are the same. That's one reason. And the second thing that could make a rational fraction an improper fraction is if the highest power of x in the numerator is greater than the highest power of x in the denominator. Now, the first thing to do is to express your improper fraction as a mixed number or as a mixed fraction. And we're going to do that by dividing. We're going to divide the numerator, 2x plus 3, by the denominator, which is x minus 1. X goes into 2x 2 times. 2 times x is 2x. 2 times minus 1 is minus 2. So if I subtract, I'm going to get the 2x goes, and 3 minus minus 2 is 5. So in other words, 2x plus 3 over x minus 1 is actually equal to 2 plus 5 over x minus 1. So in other words, 2x plus 3 over x minus 1 is the same as saying 2 and 5 over x minus 1. Now, how could we get this now? First of all, the x minus 1, if our starting point is y is equal to 1 over x minus 1, the x minus 1 would mean I would have to move the graph 1 unit to the right. So this would become my new vertical asymptote. I'm moving the y-axis 1 unit to the I'm moving the graph 1 unit to the right because my starting point was y is equal to 1 over x. So the graph of 1 over x minus 1 means I've just moved the graph of y is equal to 1 over x 1 unit to the what? Right. If I move the graph 1 unit to the right, I've moved the vertical asymptote from the y-axis to the line x is equal to 1. So this is x is equal to 1. Now, the positive 2 here is, let us say, 1 over x minus 1, and you're going to add 2 to that. Once you add 2, that is a vertical translation of 2 units. So the horizontal asymptote, which is the x-axis, is going to become hold a second, please. All right, so let me redraw this line. So the vertical asymptotes, all right. Now, if I ignore, well, let's not ignore them. We don't have to. When x is, let us say, well, you won't say x is equal to 1. When x is 2, you have 2.5. So that would be here. Or no, it wouldn't be 2.5. If x is 2, it would be 3. So that would be here. If x is 3, it would be 2.5, which would be here. And this would be 2 1/3. This would be around here. So this is now 100% accurate, guys, and I'll tell you why. I should not have placed these values in. So ignore these values. Ignore those values. All right. But the top part of the graph is going to look like that. And I'll tell you why. Because of this 5. This 5 makes it a vertical stretch. But we're not so much concentrating on the vertical stretch. All right, and the other half of the graph would look something like this. This here, this actually should be here. This should be here. This should be here. So it would look something like this. All right, and that graph would be the graph of y is equal to 2x plus 3 over x minus 2, which is the same as the graph of what? 2 plus 5 over x minus 2. All right. All right, so example 49 is asking us to use the graph of y is equal to, f of x is equal to 1 over x squared to sketch the graph of g of x is equal to 2 over x squared plus 2x plus 1. Well, maybe I was wrong, and maybe having the numbers would be a good idea here. All right, so we have our Cartesian plane. First of all, we're going to need to complete the square for this. X squared, well, it's not a big need, plus 1 is the same as saying x plus 1 all squared. X squared plus 2x plus 1 is the same as saying x. So we on the left side we have what? F of x is equal to 1 over x squared, and we have on the right, let us say g of x is equal to 2 over 2 over x plus 1 squared. So we're being asked to use the graph of f of x is equal to 1 over x squared to sketch the graph of g of x is equal to 2 over x squared plus 2x plus 1, which is the same as saying g of x is equal to 2 over x plus 1 all squared. All right, now the graph of y's f of x is equal to 1 over x squared. When x is 1, f of x is 1. So this would be a point, let us say here. When x is minus 1, f of x will still be 1. So I have a point over there as well. When x is 2, f of x would be a quarter. When x is 2, f of x would be a quarter. So that will put us somewhere around here. When x is minus 2, f of x would be a quarter, somewhere there. When x is a half, f of x would be 4. So that would put us here and here. All right, so with this, we can draw the graph of f of x is equal to 1 over x squared. You can spend the time and look into how I got these values. It's not very difficult to figure out. So this would be the graph of f of x is equal to f of x is equal to 1 over x squared. Now, from this graph, using our knowledge of transformation, we need to sketch the graph of g of x, which is equal to 2 over x plus 1 all squared. Well, in the first instance, if it's x plus 1 all squared, that's a horizontal translation. And it's the fact that it's plus 1, it means I'm going to move this entire graph 1 unit to the left. So my new vertical asymptote is going to become this line, which is the line x is equal to minus 1. And that is because of the x plus 1 square. The x plus 1 is telling me I must move the graph 1 unit to the left. Now, the 2 at the top is telling me that this is a vertical stretch by a factor 2. Now, what the vertical stretch does is that it takes the point, let us say PQ, and the point PQ becomes the point P2Q. So with the vertical stretch, for the same value of x, the value of y is going to be multiplied by 2. All right, so we'll move the 2 units to the left, and then we're going to vertical stretch. So 2 units to the left, everybody goes 2 units to the left, 1 unit to the left, sorry. And then you're going to multiply the coordinates by 2. So the point minus 1, 1 is going to become the point minus 2, 2. The point 1, the point 1, 1 is going to become the point 0, 2. You're going to move it 1 unit to the left. So if you move it 1 unit to the left, it becomes 0, 1. If you multiply the y value by 2, it's going to become what? 0, 2. So the 0.11 is going to become the 0.02. The point 2 1/4 is going to move 1 unit to the left, and then multiply 1/4 by 2, you're going to get 1/2. So 2 1/4 is going to move and become 1 1/2, which is here. All right. Now, minus 2 1/4, move 1 unit to the left, minus 3, multiply it by 2 1/4 by 2, it becomes 1/2. So, which other point now? 1/2, 4, is going to become 1 unit to the left, that's minus 1/2, and 8, which is not on our graph. So our graph is going to look something like this. Now, the blue graph is f of x is equal to x squared, and the red graph is g of x is equal to 2 over x squared plus 2 plus 1, which is the same as saying 2 over x plus 1 all squared. All right, so next we're going to look at example 50, which says, given that g of x is equal to x plus 1 over x plus 2, we're to describe the transformation that moves the graph of f of x is equal to 1 over x onto the graph of g of x, hence sketch g of x. So what do we, first of all, we're already established that x plus 1 over x plus 2 is an improper fraction. And as such, we have to first convert it to a mixed fraction by dividing the numerator by the denominator. Now, x into x is 1. 1 times x is x, plus 1 times 2 is 2. Subtract. When we subtract, we're going to get minus 1. So what this means is that g of x, which is x plus 1 over x plus 2, is the same as saying 1 minus 1 over x plus 2. So we're asked now to what? Describe the transformation that moves the graph of f of x is equal to 1 over x onto the graph of g of x and sketch g of x. These are the transformation. So you're starting off with 1 over x. If you move to 1 over x plus 2, that is a horizontal translation of 2 units to the left. That is a horizontal translation of 2 units to the left. Now, if you move from there to this, minus 1 over x plus 2, that is a reflection in the x-axis. That is a reflection in the x-axis. And if you move from that to 1 minus 1 over x plus 2, the last transformation is a vertical translation of 1 unit parallel to the y-axis. So to answer the question, this is what I would say, that f of x is mapped onto, that's what this means, g of x by, and the first one is a horizontal translation parallel, 2 units left parallel to the x-axis. That's the first transformation. The second transformation is when you move from 1 over x plus 2 to minus 1 over x plus 2, that is a reflection in the x-axis. And the third one in moving from minus 1 over x plus 2 to 1 minus 1 over x plus 2, that is C, a vertical translation of 1 unit parallel, 1 unit vertically upwards parallel to the y-axis. Those are the 3 transformation that moves the graph of f of x is equal to 1 over x to g of x, which is 1 minus 1 over x plus 2. So the first thing, remember the graph of 1 over x looks like this, where the x-axis and the y-axis are your asymptotes. So first of all, we're going to move it 2 units to the left. So this becomes your new vertical asymptote. We're going to move it 1 unit vertically upwards. So this becomes your new horizontal asymptote. All right. And lastly, you're going to reflect in the x-axis. So the part of the graph that is above the x-axis is going to come below the x-axis, and the part that is below is going to go above the x-axis. So we're going to have something looking like this. If I wanted to be specific, something like that, like that, like that, like that. So it looks something like this. And this part of it now, that would be here, here, here. This would look something like this. Now, this red graph, so this is the line y is equal to 1, your new horizontal asymptotes, and x is equal to minus 2, your new vertical asymptote. And then we reflect in the line in the x-axis. Parts below is going to go above, parts above is going to go below, something like that. All right.